Good morning, champs. How do we know whether gravity controls a flow or whether inertia dominates it? The answer is hidden inside a dimensionless number called the Froude number. Today, we'll derive it from scratch using dimensional analysis and a Gauss-Jordan tableau. Suppose the flow behavior depends on velocity, gravity, and a characteristic length. We denote these as V, G, and L. We now assume a dimensionless group equal to V raised to A times G raised to B times L raised to C. Next, we convert every variable into SI base units. Velocity is meters per second, gravity is meters per second squared, and length is simply meters. Substituting these units into the dimensionless group and collecting powers gives meters raised to A plus B plus C times seconds raised to negative A minus 2B. For dimensionless quantity, the exponents of meters and seconds must both equal 0. This gives us two equations. Now we write the system as a matrix and build the Gauss-Jordan tableau. Applying row operations reduces the matrix and gives the relationships. A equals negative 2C and B equals C. Choosing C equal to negative 1/2 gives A equals 1 and B equals negative 1/2. Substituting these exponents back into the dimensionless group gives V divided by the square root of G times L. And that is the Froude number. The Froude number compares inertial effects to gravitational effects. If the Froude number is less than 1, gravity dominates the flow. If it is greater than 1, inertia dominates. This number is extremely important in ship hydrodynamics, river engineering, spillways, and hydraulic jumps. Whenever gravity strongly affects moving fluids, the Froude number becomes important.